about baseline performance, step number 6. And already you learned certain tools to measure the baseline performance, yield metrics, first pass yield and throughput yield, and DPMO metrics, DPMO as well as PPM, right? And now it is for CPCPK. So process CPCPK are called process capability indices. But post lunch, I'll be discussing explaining you process performance indices. The capability indices are CPCPK, performance indices are PPPPK. And then we will discuss few cases. Now, process capability indices CP and CPK. Two metrics are important to conclude on the capability always. Because always there are two ways things can go wrong. There are two ways things can go wrong. One is the variation can become a problem. Another thing is the central tendency can become a problem. Isn't it? Like in your measurement error also, precision can go wrong, accuracy also can go wrong. Same way, precision is because of the inconsistency. Inconsistency is the variation. Variation can go wrong. Accuracy, closeness to the true value. Where do you see the true value? In the central tendency. Central tendency, when it is close to the target, then things are going good. Similarly, consistency, if you are more consistent, then things are going good. So you probably can go wrong in two ways. Either spread can increase or central tendency can move away from the target. You call it process shift. That is why we need two metrics, CP and CPK. CP will monitor the spread, CPK will monitor both spread and the central tendency. It's a good way of monitoring only the spread or monitoring both the spread and central tendency. What is your opinion? It should be, we should keep an eye on both, right? So CPK is the best measure, but then CP also gives some useful information. CP will also be helpful. If you understand what CP is doing and what CPK is doing, then you can use both of them for the betterment of your results, right? And now CP. CP is called potential process capability ratio. And CPK is called process capability index. And according to the formula, CP is specification width divided by process width. What is specification width? USL minus. Then what is process width? UCL minus LCL. Then what is UCL?
Upper control
Tendency plus 3 sigma. What is LCL? Center value minus. So this understanding is very clear. And so, what is the distance between UCL and LCL? 6 sigma.
Yes.
From the center, move up by 3 sigma, you get upper control limit. From the center, move down by 3 sigma, you get lower control limit. So what is the distance between UCL and LCL? 6 sigma. So USL minus LSL divided by 6 sigma is the formula for CP. Is the formula for CP. But how do you calculate the sigma? How do you calculate the sigma is very important. You can calculate the sigma in several ways because several formula exist. Sigma can be calculated as R bar by D2. You can simply calculate sigma using the formula R bar by D2. You can also use the formula summation of, square root of summation of x minus x bar the whole square divided by n minus 1. If you understand what this formula are doing, if you also understand how you collected the data, then you will understand what is going to be your result. Whether your result is going to be CPCPK or it is going to be PPPPK or even in CPCPK itself, there are terms like within capability, between capability, between capability. People can easily get confused because there are several terminologies. But if you stick to the basics, listen very carefully, then you will really become a black belt and then handle everything comfortably. Right now, you can use this formula for CP. This formula is called within standard deviation, within batch variation, within batch variation. And so the capability you are going to get using this sigma will be within capability, right? And coming to the process capability index, the formula is minimum of CP upper and CP lower. So what is CP upper? USL minus X bar divided by 3 sigma. What is CP lower? X bar minus LSL divided by 3 sigma. You don't have to remember this formula because when you little slightly visualize this formula, it will be very easy for you to remember. Now, let us consider a process. Let us consider a process where surface finish, flatness, or something is measured in terms of, let's say, some micron. Let's say the customer target is 40 microns. Customer target is 40 microns. And customer gives a tolerance of plus or minus 10. So 40 plus 10, what is your USL? 50. 40 minus 10, LSL is 30. Now you will run a process. You wanted to be careful. So you will see to that your control limit is staying inside the specification limit, right? And so the upper specification limit is 50, lower specification limit is 30. And you wanted to understand how good is your process. So you picked up some data from the process and calculated X bar. I'm sure you know how to calculate X bar, right? You collect the data and calculate X bar. X bar is found to be 40. What is your understanding? When your X bar is found to be 40 or the calculated average is found to be 40, what is your inference? Can one of you tell me now?
It's a central line, sir.
Process is centered correctly on the target. Can I say like that? Process is centered correctly on the target because customer targeted value is mu, that is also 40. Process average also 40. Is it good for your results?
Yes.
For your result. It is good. So try to get your process average on the target. All of you get this idea?
Yes.
Yes. Now, since your process average is on the target, does it mean all your outputs are exactly on the target? I need an answer now.
It cannot be exactly on the target, but within 6 sigma.
Average is on the target. Still, individual values can be away from the target. So you need to control that also. You need to ensure that all the products that are all the outputs that are coming out from your process are closer to the center. Earlier, you ensured that your center is on the target. Now you need to ensure everything is around the center. Everything is around the center and center is on the target. That means everything is good. So keep an eye on the center. Also keep an eye on the variation. That's why we have got two eyes. One eye should be average, other eye should be on the variation. How do you measure variation? Use standard deviation. With the corrected data, you will be able to calculate standard deviation. Let us assume the calculated standard deviation is equal to 2. What does it tell you? When sigma is 2, you can immediately locate the control limit. Am I correct? What will be the distance of control limit? 3 sigma from the center. Sigma equal to 2. So 3 sigma will be 6. 6 plus center. Center value is how much? 40. 46. 46 is your upper control limit. 34 is your lower control limit. All of you understand how did I get USL, LSL, UCL, LCL?
Yes.
Now formula CP equal to specification width divided by process width. Simple.
Sir, one more time, sir. Sorry. Sir.
Yes.
One more time, this LSL, the USL.
LSL and USL are generally given by the customer. It may be end user or your own designer will tell you. This is the LSL. Whoever is the customer, to listen to him and understand. So customer says, I need 40 micron plus or minus 10 microns. This is the my specification.
Okay.
Customer target, I use the symbol mu for customer target, and USL is 50, LSL is 30. How do I get USL? 40 plus 10.
From customer. Okay.
And what is 10? Customer provided tolerance.
From customer provided tolerance. Okay.
Understood?
So LCL, sir. LCL how to calculate, sir? LCL and
LCL, yeah. See, UCL, LCL, if you want to calculate, you must collect sample first of all.
Okay, sir. Okay.
Collect sample from the process. From the sample data, calculate the average. That is going to be X bar. The X bar is called process average.
Okay, sir. Okay.
Process average. And using the same sample data, calculate standard deviation. Let us say the calculated standard deviation is 2. Once the calculated standard deviation is known, go for the formula process average plus 3 times standard deviation. That will give you upper control limit.
So process average.
Process average plus 3 times process standard deviation. That will give you upper control limit. Similarly, lower control limit. Is that clear?
Okay, sir. Clear.
Right. And now I apply the formula. Specification with USL minus LSL. How much? Can somebody tell me USL minus LSL? 50 minus 30?
20.
20.
20.
And UCL minus LCL. 46 minus 34?
12.
This is also equal to 6 sigma. 6 times sigma. 6 into 2 also 12. So what is the CP value? 1.67. Now tell me, is your process capable?
Yes, sir.
Yes, sir.
Definitely capable. You are seeing the control limit well inside the specification limit. So your process is capable. Because once you know control limit, normal distribution property, afternoon RK will be explaining, you are very sure that 99.73% of your outputs lie inside control limit. Since control limit itself is lying inside specification limit, you are also very sure that at least 99.73% of your outputs will be accepted by the customer. Can I say like that?
Yes, sir.
Very important statement I made. Normal distribution is telling me that always 99.73% of the outputs will lie inside the control limits. Your process cannot produce easily outputs beyond the control limit because there is very less chance that your process can produce output beyond control limit. That chance is limited to 0.27%. But 99.73% chance is there that your process can produce output only inside the control limit. So with this knowledge, I am now making a statement that at least 99.73% of the process outputs are going to be inside the specification limit because I know my control limit is inside specification limit. Is that clear?
Yes, sir.
And that is reflecting in my CP value. When CP value is more than 1, that's the situation. My statement can give correct findings. My statement will hold good whenever CP value is more than 1. So more than CP more than 1 means you can consider your process as capable. But CP sometimes can give a false alarm. When you can go wrong, when CP will give a false alarm? CP will give a false alarm if you look at only the value of CP and without referring to this diagram. This diagram, see, you are actually you have made the conclusion using 2 things. One is using the CP value. Another thing is you are very sure that your control limit is inside the specification limit. Am I right?
Yes.
If the CP is more than 1, control limit is not inside the specification limit. Do you think your statement will hold good?
No.
That you should be very, very careful, right? So if you can see control limit inside specification limit, CP is more than 1, you can say your process is capable. So that is why when working with the CP has got limitation. That is why people use the CPK instead of CP. So CP is limitation. Now we will understand. See here, my process spread is now increased. You know why my process spread increased? Look at the sigma. Sigma earlier was how much? 20. Now it is 4. Now I calculate the control limit. Now see where is my control limit? Is it inside the spec or outside the spec?
Outside the solution.
Outside.
Now my statement will not hold good. 99.73% of the outputs will lie inside control limit, but definitely some of them will be outside the specification limit. All of you understand now?
Yes, sir.
Now you can't make predictions using control limit. There are rejections going to happen. So now under such situation, your process is now considered not capable. Your process is now considered not capable. Why? Because the control limit has exceeded the specification limit, has crossed the specification limit. Under such situation, if you calculate the CP now, look here, specification width divided by process width. What is the specification width? Again, it is 20. What is the process width? Can one of you help me calculate? How to calculate?
UCL minus LCL, sir.
UCL minus LCL. Otherwise, 6 times sigma. Both will give same value. Look here, 24. Now look at the value of CP. CP less than 1 means your process is definitely not capable. There is going to be definitely rejections, 5 to 10%, or it can be any percent. Because rejection not only depends on the position of the control limit, it also depends on the position of the central tendency, which is process average. Now, in this diagram, central tendency is not a problem. Even now, process average is on the target. But what is the problem? Control limits are the problem. Control limits got widened. So the damage is only due to the standard deviation, not due to the average. Anyway, process is not capable. All of you understand the meaning of CP going below 1 and CP going above 1. Clear?
Yes, sir.
Very good. And now there is one more chance. Look here, one more way. Now, my process center is shifted, but standard deviation remains same. Process center is shifted, but standard deviation remains same. Now, where is my upper control limit?
Exceeds
It's
the
outside the specification limit.
Upper control limit is outside the specification limit, but lower control limit is inside only.
Yeah.
Do you think my statement will now hold good? 99.73% of the output will be inside the specification limit. Will I be able to make the statement?
No.
No, I should not make because my control limit has exceeded. But now check your CP value. Specification width is how much? 20. Process width is how much? 12. CP equal to 1.67. But according to our earlier discussion, CP is more than 1. Can I now conclude my process is capable?
No.
That is the no. That means CP can mislead you if you refer to the CP value without looking at the control limit. Am I correct?
Yes.
And it is always impossible for you to draw a diagram like this and see where is your control limit. In your company, you just look at a value and then quickly you take a decision. So my recommendation to all of you is don't look at CP hereafter. Look at only CPK. So just with the value, you can take a call whether your process can be capable or not. All of you understand the limitation of CP now?
Yes, sir.
Okay.
This is the reason for having another metric, another tool, CPK. CP monitored only the position of the control limit. It failed to monitor the position of the central tendency. However, CPK will monitor control limit as well as the central tendency, and that is why it is better than CP. Now come here, look at this situation. Can you please, now I want the black belts here to make some comment, some conclusion, looking at the slide now. What do you think about the process capability now? Go ahead. Come on, make your predictions. Is this process capable?
No, sir.
Why not capable?
It's a risk, sir. Like both are overlapping, USL and UCL.
Specification limit and control limit are overlapping. That means my process is just made it, isn't it? It just made it, just capable. Can I call it just capable? Come on.
Sorry, sir.
Can I call it just capable?
Yes, sir. Just capable. For a long term, it will not be good.
Just capable. For long term, there could be problem, but as of today, it looks good. At least I am sure that 99.73 can be inside specification limit in short term. So what is the CP value in this situation? When control limit overlap with specification limit, what is the CP value?
Just 1.
Yes, equal to 1. Specification width is 20. Process width also 20. CP equal to 1. When CP equal to 1, no, see here, process center is here. Nearest to specification limit is here. What is the distance between process center and the nearest to specification limit? Can one of you tell me what is the distance?
3 sigma, sir.
3 sigma, beautiful. Is equal to 10 units. 10 units means 3 times sigma value, 3.33. So the process is called 3 sigma process. All of you understand how the sigma level is arrived? All of you understand how the sigma level is arrived?
No.
Yes or no?
For me, okay, sir.
Partly
No, for me, okay, sir. But
for you know.
yeah.
How about others?
To answer.
All of you understand the relationship between CP and sigma level? CP equal to 1 and sigma level equal to 3. How did I get it? Oh, multiply CP value by 3, sigma level. All of you understand?
Yes, sir.
Yes, sir. Yes, sir.
Right. And okay. So
It means, sir, if we are using the whole customer given tolerance, it means CP is 1.
yes, if you use the entire customer tolerance, your CP is 1.
Okay.
Right. If you use only half of the tolerance, your CP will become what?
2.
When CP becomes 2, what will be your sigma level?
6 sigma.
Beautiful. You need to be doubly capable. When customer gives a tolerance, don't exploit everything. Use only half of it. If your father has given you 100 rupees back, it is not advisable you spend all 100 rupees on the same day. Spend only 50 rupees. Remaining 50 rupees can be used for the future requirement. Am I correct?
So it means, sir, for that particular CTQ, my sigma level is 6 sigma.
Very good. Beautiful.
Particular
Attended
CTQ.
any of our course already, Mr. Vikram?
No, sir.
Oh, very good. Because you are talking very perfectly. For a particular CTQ, sigma level is calculated. Many people, out of 100 people, 99 people don't talk like this. They'll say sigma level is for the entire company. My company is a Six Sigma company. Your company will never become a Six Sigma company. Only your process, at that too at the CTQ level, sigma level is measured. Because a process can have so many CTQs. You will not have time to measure the CTQ of all the sigma level of all the CTQs. For the critical CTQs, you can measure sigma level. Beautiful observation. Done. So now moving on. So now we understood the limitation of CP. What is the limitation of CP? It is not monitoring the location of the central value, isn't it? So we need another metric called CPK. CPK is nothing but a broken down version of CP. See here, specification width is divided into 2 parts. Right side it is represented in blue color. Left side it is represented in green color. The total length is specification width. Now specification width is divided into 2 half. Now what is the length of blue color bar? Can I say USL minus X bar?
Yes.
Similarly, green color bar length is X bar minus LSL. Similarly, your process width also you divide into 2 parts. Total length is 6 sigma. When I divide into 2 parts, 3 sigma on the right side, 3 sigma on the left side. Clear?
Yes, sir.
Blue bar divided by 3 sigma is called CP upper. See here, USL minus X bar by 3 sigma. Similarly, green bar divided by 3 sigma is CP lower. When your process is centered on the target, your CP upper and CP lower will give same value. Am I correct?
Yes, of course.
Yes,
Right?
sir.
Whether you calculate CP or CPK, if your process is centered on the target, both are going to get you the same picture. Look here, CP upper also 1.67, CP lower also 1.67. Now you calculate CPK, CPK will also give you 1.67. So certain occasion, CP value will match with the CPK value. That means what? Your process is centered on the target. But when the CPK will differ from CP, when your process center is shifted either to the right or to the left, CPK will start differing from CP. For example, imagine your process is shifted to the right. Now what will happen to the blue bar? Will it increase or will it decrease? Let us say process center is shifted to the right. What will happen to the blue bar?
It will decrease, sir.
Blue color bar will decrease. If the blue color bar decreases, CP upper will go down. Whichever side value is decreasing, that side your control limit can exceed the specification limit. Am I right?
Correct.
And so the formula will always pick up the minimum of the 2 values. Because whichever side is the risk, I want to know that. So that is why we have the minimum here. CPK is minimum of CP upper and CP lower. When process shift to the right, then I will take CP upper. When the process shift to the left, then I will take CP lower. All right. Now, tell me which side process is shifted, to the right side or left side?
Right side.
Right side.
So CP upper is going to be your capability. See here, CP upper reduced from 1.67, CP upper reduced to 0.833. But CP lower will increase, obviously. But which one you will take as capability? 0.833 only. All of you now understand?
Yes, sir.
So which is the best measure of capability? CPK is the best measure. If the process is shifted, then damages can be more. Damage is not only due to the control limit, damage is also due to the location of the central tendency, right? And so CPK is the best measure. All right. Fine. So now how to take a decision? My opinion, my recommendation to all of you. Always look at the CP also, look at the CPK also. If you want to only look at one out of the two, tell me which one you will look at. You will look at CP or CPK?
CPK.
If you wanted to look at only one of the capability metrics, use CPK. Never go with the CP alone. I don't know how you are doing it in the company. Most of the time people use CP, but that is not good. If you want to only look at one metric, then it should be CPK. But my recommendation is look at both. What is required is CPK should be more than 1.67. See here, CPK should be more than 1.67. If CPK is more than 1.67, there are two things that are guaranteed. One is your outputs are consistent. You know meaning of consistency, right? Your outputs are consistent. Another thing that is guaranteed is your outputs are also good. That means customer will accept all your products. You boldly send your lot to the customer place. Customer, whatever way he checks, he has to accept all your product. So that is the guarantee CPK gives. Got it?
Yes, sir.
But if you look at CP, it gives only one guarantee. Your outputs are consistent. It may be good. There may be some bad items also inside. Am I correct?
Yes.
So don't send your lot just looking at the CP value. It only talks about the consistency, doesn't talk about whether it is good or bad, whether it can be accepted or rejected, right? Customer can still reject even if you have a higher CP value. Then why should we have a CP? Then why should we have a CP? For example, let me say my CP is 1.85. My CP is 1.85. My CPK is 0.8. What is it telling you?
Central tendency not shifting.
You have very good consistency. You have very good consistency. Variation is very low. Sigma is very low. When sigma is very low, it is very easy to shift the mean. When sigma is very low, it is very easy to shift the mean. When you shift the mean, what will happen? Your CPK will suddenly increase from 0.8 to 1.85. So a very good opportunity exists for improving your capability. How do I understand? Looking at the CP value. At the maximum, CPK can become equal to CP. At the maximum, CPK can become equal to CP. Whenever you see CP equal to CPK, immediately you can understand your process average and customer targets are at the same place. The best scenario. This is also difficult to get, right? But when CP differ from CPK, you can understand your process center is shifted. Center shifted, still your outputs may be accepted. For that, you have to look at the value. Generally, according to AIAG guideline, Automotive Industry Action Group, for critical process, CPK must be 1.67 minimum. For critical process, for critical product, right? But for non-critical process, CPK must be minimum 1.33. Right? When I say CPK must be 1.67, I also mean CP should also be 1.67, isn't it? Because your CPK cannot be, more than CP. When I say CP more than 1.67, what is the other statement automatically included? CP should also be more than 1.67. All of you understand the requirement? For critical process, CP and CPK should be more than 1.67. For non-critical process, CP and CPK should be more than 1.33. Any questions? Any questions on
No,
CP?
sir.
Maybe after the lunch, I'll take you through few cases, right? Maybe